Hello, you're welcome to my channel. This is Tech with Helen channel where you can actually learn anything about DevOps, cloud, and other IT related topic. Alright, so you're at the right channel. In this video, we'll be learning how to build a custom VPC using Terraform, a VPC and the component actually. So this will be like a two-tier architecture, alright? So I'm going to show you from the scratch. So if you don't have knowledge of practically using Terraform, you don't have to worry. So whether you're a beginner, intermediate level, you're welcome. Please subscribe to this channel and click on the notification bell so you don't get to miss out on my subsequent videos. Now this architecture looks like this. We'll be creating a custom VPC, and then we'll have two public subnet which will help us to basically expose something like a load balancer. So let me just paint a scenario. Imagine you want to deploy a web application and you don't want basically you want this to be two-tier, right? You don't want to maybe like involve a database. So creating two public subnets can actually help you to expose your, let's say you're using an application load balancer, so you can actually create that load balancer in a public subnet. So this networking solution is what you have to do first to build like that foundation for your AWS architecture, network architecture. So we'll be creating two public subnets in two different availability zone. One will be in US East 1A, the other one US East 1B, and then we'll create a private subnet AZ1 in US East 1A and the other one in US East 1B, so making it a total of four subnets. All right, and for these two subnets, the public subnet will be associated with a public route table, and the route to that will be an internet gateway. So in order for this to have access to the internet, in order for the resource that will be deployed in this subnet to to be exposed to the internet, we are actually using an internet gateway. So internet gateway acts as a gateway for internet bound traffic. So for the private subnet we have here, we will be creating a private route table and then associate the subnet to it. We'll also associate a NAT gateway. We'll link it to this private route table. Okay, so with NAT gateway, it will basically allow you to initiate outbound traffic to the internet. It will allow your instances in private subnets to initiate outbound traffic to the internet while preventing inbound traffic initiated by the internet. So just for security purpose, we can use this NAT gateway. We'll also create elastic IP address that will be associated with this NAT gateway. Okay, just to have a fixed public IP. All right, so this is what the architecture will look like. We'll be using this CIDR for our VPC. So to get started, if you want to follow along in this video, just come to this repository which I'll be dropping its link in the description below. Just once you open that, you may want to fork it. So forking it will allow you to just copy this code over to your GitHub account. So you can click on fork here, and then once you fork it, you can then clone it. Just ensure that the HTTPS is highlighted. Click on this to copy it, and then go to your terminal and run git clone and paste the URL in order to download the code locally to your computer. I'll be using VS Code for this video. Alright, so we can get started. So having cloned my repository, I have it here already. You should be able to see all this file if you're following along. Alright, let's begin by putting our configuration files together. Actually, let's begin with this providers.tf. Although I have the templates already for all these files, but then we'll be customizing them. All right, and I'm going to explain whatever configuration file or block we'll be using in this video. So we have providers.tf, and what is this providers.tf? This is actually a way to declare provider configurations for your infrastructure. Providers in Terraform are responsible for interacting with APIs of various cloud or service providers in order to provision and manage resources, and in this case, AWS resources. So here we have Terraform block. So Terraform block defines settings for Terraform itself, all right? So inside this block, we have required providers, which specifies the required provider plugins for our Terraform configuration. So here it's indicate that Terraform configuration requires AWS provider, okay? And within this AWS provider, we have the source. So this source specify where the provider plugin, where to basically find the provider plugin, okay? So it will locate HashiCorp /AWS, and then this version specify the version of the provider plugin required by the Terraform configuration. And here we have provider block. This block configures AWS provider for our Terraform configuration. So we have AWS provider here, and we'll be using US East 1 region as our default region, okay? And then the profile here, I have Helen, because in AWS I have a user called Helen, so you need to check what you have there and use the same name, okay? If you are Mike and you have a user in your AWS account called Mike, you may want to use that so that it will use that as a profile for provisioning your resources, okay? So ensure you replace Helen with your username, all right? Now let's go over to vpc.tf, okay? Don't bother about this red color that it gives us. It is basically showing us that our configuration file is not well configured, so we need to customize this and fill in these parameters before we can have them right, okay? So this is a template to create a custom VPC and its components. Before we go ahead, I would like to show you how you can actually get all these components yourself, so that if you're constructing this from the scratch, you can actually know how to go about putting all these blocks together to form a configuration file. Type Terraform provider, click on this browse providers, close out this, and then you should be able to see all the providers here. Click on AWS. So the providers block that we used, I got it from here, okay? So this is what I'm using. I just copied this, okay? The only thing I added is the region and my profile. That was what I added here, right? So I want to show you how you can get all the resources that you want for your Terraform configuration. Just click on documentation, and here type whatever you want. If you want to create AWS VPC, if you want to get the block for creating AWS VPC, okay, you can see under resources you see AWS VPC. Click on that, and you should be able to see example usage, okay? So this is the basic usage. So if I scroll down here, you can see argument reference. So this resource supports the following argument. So you should be able to see all the arguments that it supports. So you don't go on to to add your own arguments, right? So these are the arguments or the parameters or the attributes, whatever you want to call them, okay? These are the attributes, right, for this VPC resource. So this is how to search for whatever resource that you want to create in AWS, right? Okay, so coming over here, we'll have, let me explain the custom VPC and the components that we'll have to provision. So basically, to summarize what I have here, before we start going into each of them, right? We'll be creating a custom VPC with 2 public subnets, 2 private subnets across multiple availability zones, and then we'll create internet gateway for internet access. Then we create a NAT gateway. A NAT gateway will allow our instance in private subnet to securely access the internet. And then we'll also have associations between subnets and routables for proper network traffic management. Okay, so let's begin with the custom VPC. So in this custom VPC, we need to add a CIDR block here. But this CIDR block, I don't want to just hard code it. So let me create another file called variables.tf. So in order to start with the VPC CIDR variable, let me just comment that this is variable for VPC CIDR. Begin by writing variable space. Inside this double quotes, I'm gonna write the name I want to choose for this VPC CIDR. Okay, I will name it this way, and then I want to open up this curly braces, right? And then inside this block, I want to have my description for this variable. Okay, so I need to have equals to inside double quotes. I want to type that this is VPC CIDR block, VPC CIDR block variable, right? And then I want to type the type as variable, as string. So a string, so the value we'll be having for this would be a string. Okay, and I don't want to give the default value here, because you can actually give the default value here as value, but then I don't want to have the default value here because I want to use what we call terraform.tf as in adding the values, okay, for our CIDR block. But this is how to create a variable input for your configuration. So what I need to do now is to copy this, the name for this VPC CIDR variable, go back to my vpc.tf file, so we can reference that. How do you reference your variable? That is by typing var dot, then I paste what I copied, and this is how to reference your variable. Okay, so for the instance tenancy, we'll be leaving it as default. And before I go ahead, I've actually created a VPC and component. All right, so you may want to check out this video. You may see that pop up on your screen, or you can get the link from the description below, so you can watch that. In case you're not familiar with creating VPCs and the components, okay, you can actually get familiar with that so that you'll flow. So for enable DNS hostname, we'll set that to true, and then the tag name for our VPC, I want to choose let's do dev VPC. Okay, and this will basically create a VPC for us. So let's go down to creating internet gateway for this block. So the way I've structured all this template is that with what you have here, you can easily copy this name in case you want to search for this block. All right, in case you want to search for this resource block, you can basically copy this, right? You can see how I named them: Terraform AWS create internet gateway, Terraform AWS create subnet. So once you copy that, you can search for it from your browser and you will see it. Okay, in case you don't want to come here and be looking for a particular resource, this is another way to directly locate it from your browser. So to create internet gateway, we have this. Okay, this is what This is what the documentation says we should use as the template. So VPC ID. How do we create an internet gateway and attach it to our VPC? That is by using the VPC ID. How do we get the ID? It is by copying this VPC type and the name. Remember, when you have a resource block, what you have here is the resource name, the resource type and the resource name. So to get the VPC ID we can use over here, I need to copy this, just copy it the way it is, come here and paste it, get rid of these double quotes and add dots in between them, right? Remove this and then .id. Okay, once you copy that, get rid of the double quotes, use .vpc to join them, and then type .id. That is actually the attributes. Okay, so with this, the internet gateway will be linked with your VPC, and then the tag for this internet gateway is dev internet gateway, right? Now let's create our first public subnet. Okay, to create this public subnet, we have this resource block. The resource name is AWS subnet. The resource type is AWS subnet, and this is the resource name, or you call it resource identifier. So for this VPC ID is actually the same VPC that we are using, and since we have it here already, we can copy that and paste it here. Great. For the CIDR block, so what CIDR block can we use for this first subnet? So this CIDR block, I don't want to hard code it. Let's use a variable for that. So if I go to my variable file, let me copy what we have here and paste it here. And so I'll delete this, delete what we have here, and this is what I want to, this is the name I've chosen for the first public subnet, which we'll be creating in availability zone 1, which I'll basically want it to be in US East 1A, right? So the description we give this is public subnet is one CIDR block, right? And the type is string as well. So in order to reference this variable, I'll just copy it, going back to VPC file. To reference that, I need to type var and then paste this. Okay, and for the availability zone, we'll be using US East 1A. Great. For the map IP on launch, this basically means that we want to assign public IP on launch. So that is set to true. And for the tag name, we'll leave it as public subnet AZ1. Great. Now let's create the second public subnet, which will be named public subnet AZ2. Okay, please take note of how the naming convention is going. For the VPC ID, it's actually the same VPC ID, so it's already here. And for the CIDR block, we also need to, let me go back to the variables.tf file, copy this. We need to have okay, there's actually, sorry, please, I need to correct this. Okay, so public subnet AZ2, great. So I also didn't see this. What's happening? CIDR, okay. So to reference this, I will copy that and go back to vpc.tf file, and to reference that var.id, and I'll paste this, and that is it. Availability zone will be US East 1B, right? Map public IP on launch is set to true. Great. Public subnet AZ2 is the tag name for this second public subnet. And then let's go over to creating a route table. So it will basically help us create a route table and add public route to it. Okay, so here we have the resource block for creating a route table. So this public route table, the first parameter we have here is VPC ID, and the same VPC ID we'll be using is here already. For the route, I want us to use this CIDR block, basically open from anywhere. That's why we are using 0.0.0.0/0. And what will be the gateway ID here? So this gateway ID will be our internet gateway, which we've configured already. That is the way we can, add a route to it to have access to the internet. So I'll just scroll up and then copy the resource type and the resource name. Just copy the way it is, and then if I scroll down, I'll paste it here, and then just remove this double quote, and at the middle type dot to join the resource type and the resource name. Okay, get rid of the double quotes at the beginning as well, and at the end just type, at the end here just type dot ID. Okay, that is the attribute. So with this, you can make use of the internet gateway as the route, and the tag name is public route table. And to associate the public subnet AZ1 to public route table. Okay, so we need to associate our subnet to route table. And how do you associate that? This is the template we have for it, and if you search for it, this is exactly what it will give you. Also note that this is dynamic, meaning you can actually give it whatever name you deem fit, but this is static. You can't change the resource type. So we need to add a subnet ID and a route table ID. What is the subnet ID? We need to get the subnet for our public subnet AZ1. Let's scroll up and get to the resource block for public subnet AZ1, and just copy this. All right, copy the resource type and the resource name, scroll down and paste it. Remove this from the end and add .id. Come and remove these other double quotes and add dots at the middle to join them, and remove this. I believe you now understand how we can get IDs for all these parameters, right? And for the resource table ID, for the route table ID, what ID are we supposed to make use of in this case? We have to get the route table or the public route table ID. How do we get it? This is by going to the route table configuration block and copying this, coming down here to paste it, because we are telling Terraform that this is the route table that we want you to associate the public subnet to. Okay, for this second block, we have to associate our public subnet AZ2 with the public route table as well. Okay, and how can we associate that? It is simply by going to the public subnet AZ2 and copying just the way we've been doing it. Okay, and that's how we got this. And for the route table ID, is actually the same ID we have here. because we just have one public route table. Okay, great. So can scroll down, and then let's create private subnets. We'll be having two private subnets. So the first one here requires the VPC ID, and I added it here already. So for the CIDR block, we need to have an input variable for that. So I go back to variables.tf file, I copy what I have here and then paste it here. Okay, so to rename this, I want to have the name as private app subnet AZ one CIDR. This is AZ1. Okay, and for the description, I want to have the description as private app subnet AZ1 CIDR. The type is string. So going back to the VPC, okay, we actually need to copy that first. So let's copy this so we can reference that. So here, to reference that, I'll just type var and paste what I copied, and that is done. The availability zone is US East 1A. The map public IP on launch is false. Why is it false? Because this is a private subnet. We don't want to assign a public IP to that. Okay, this is the tag name, and then we go over to creating private app subnet AZ2. This is the VPC ID we've been using, and for the CIDR block we also need to have input variable for that. So I'll just copy this and paste here, and then I want to rename this AZ1 to AZ2, and here I'll change the AZ1 to 2, and that is it. So I'll copy this name, so we go and reference that. Okay, var dot this, and that is done. It is being created in US East 1B. Map public IP on launch is false as well, and this is the tag name. Great. So this is what we need to do for this VPC and the component. We are not actually done with it because we also need to create a NAT gateway, but we have a different file where we'll be configuring the NAT gateway. So basically this block will allocate elastic IP address to the NAT gateway, so it will be used by NAT gateway in the public subnet AZ1, right? Because the NAT gateway we'll be creating will be in public subnet AZ1, so we need elastic IP for it so that it can have a static IP address. So this is a block, the template for it. The domain here is equals to VPC. Okay, this specifies the domain for our elastic IP address, and in this case, it is set to VPC so that it can allocate the elastic IP to use within the VPC, and this is the tag name for that. Okay, so going down, let's now see how we can create our NAT gateway. So this is the resource block for creating NAT gateway. This is the name I chose to give to my NAT gateway as the identifier, right? And the allocation ID, what should we have here? Allocation ID basically specifies the allocation ID of elastic IP address, right? That will be associated with the NAT gateway. How do we associate the elastic IP address? So this is where we'll be doing the association basically. All right, so just copy this. Remember the way we've been doing it. At the end I want to add .id, and at the middle here I'll delete this and add dots. Go to the beginning and remove the double quotes. All right, so this is how to add the allocation ID. And for the subnet ID, we want to create this NAT gateway in a public subnet, and that will be public subnet AZ1. Remember, your NAT gateway should always be created in a public subnet. So how do we get the subnet ID? I need to go back to vpc.tf and go to where we have the public subnet AZ1 and copy the resource type and the resource name. Then go back and paste this stuff here. Remove this, add ID at the end. Get rid of this and add dots and then delete this. Great. So that is done, and this is the tag name. So going down, so coming over here, this is not actually supposed to be here. We don't need to have any depends on dependency here, so just get rid of this. And then the next block that we have here is to create a private route table. We need to create a private route table as one, and then we add a route through NAT gateway. We can't create a NAT gateway without having a private route table, okay? Because it will just use NAT gateway as the route, okay, through which our private resources will have access to the internet. So this is the resource block for it with the parameters or the attributes, right? So the VPC ID is the same VPC ID we've been using and is already declared here. And then this is the route. How do we want to add the route? The CIDR block should be from anywhere, and it's okay like this. Now the NAT gateway ID, how do we get it? Can you guess? Okay, to get that, we just need to come here where our NAT gateway resource is. By the way, I need to add this curly braces here to close it out. So I just need to copy this and go back, then paste it here, delete this, add the ID, come to the middle and delete this double quote here, delete the first one. Okay, I didn't add the dots in between. Okay, great. So going down, this is the tag name for this private route table. So with this, we've associated the NAT gateway, we've added it as the route to the route table. Okay, so in this block, we want to associate the private app subnet as a 1 with the private route table as a 1. Okay, because you can't have a private route table without associating it with a private subnet. So how do we get the subnet ID? I have to come over here, look for where the block where we've configured the private app subnet is a 1. So I just have to copy this, right? Go back where, okay. Just add id.id at the end and get rid of this, add dots at the middle and delete this. Okay, route table ID. How do we add the route table ID that we want to associate this subnet with? Just by scrolling up to the private route table. We can copy this here and okay, and I need to paste it here, then delete this, add .id middle and delete this. Great. Now what we have here lastly is to associate private app subnet as a 2 with the private route table as a 1. We need to go to VPC file, right, to get the subnet ID for our private app subnet as a 2. Let's come over here and get to this block. So for the private app subnet as a 2, I need to copy this, I hope you understand how this is going, and in case if it's confusing, that is why I've recommended you watch that video where I created custom VPC and the components. All right, so you can learn how you can do that from the management console, so that this will be easier for you to understand. But I hope you're following. So having copied this, let's go back to our NAT gateway TF file. So I'll paste this, add .id, come to the middle, get rid of this and add dots, and then I'll remove this. Route table ID. So we actually created a private route table. We just have one private route table. So it is the same route table ID that we use here, that we'll be making use of here. And that is done. So with this, we've actually configured our VPC and the components. All right, now we can actually go ahead to create a file called terraform.tfvars, all right, which is where we can add values for our input variables here. Okay, so in order to have a value for this, which is even more flexible, you can actually easily modify your value over there than having everything here, and is also is a better way to manage your value basically. All right, so I'll just right click here and create new file. So we name this terraform.tfvars, press enter. Okay, so how do we go ahead and how do we add these values here? Let me close out this VPC. So I want to split my screen right now. So to split it, this is the split icon here. Great. So we have terraform.tfvars here, and we can have variables here so that we visualize what we are doing. Can just close out this. Okay, so so let's start from the first variable we have here. So we have a VPC side. How do we give a value that Terraform should use for our VPC CIDR? So to do that, all I need to do is to copy this variable name. All right, so all I'll be needing from here is each of the variable names. So once I copy that, I paste that here. I'll type equals to, then open double quotes and type the value that I want to assign to my VPC CIDR. So I would like to assign 10.0.0.0/16, and that is done. Move to the second line and get to the second variable here. So I copy this one, public subnet AZ1 CIDR, paste it here, equals to, open double quotes. So the value that I want to assign to this is 10.0.0.0/24. Then let's go to the third variable here, public subnet AZ2 CIDR, and then paste it, equals to, open double quotes, and so this should be 10.0.1.0/24. Okay, and for the third one, the fourth one here, private app subnet AZ1 CIDR, I'll paste it here, and then equals to 10.0.2.0/24. And then for the second private app subnet, copy and paste that here, equals to, open double quotes, 10.0.3.0/24. Sorry. Okay, so this is all we have to do to assign values to our input variables. So having done this, I can actually save all. Then I can close this out, and then I can commit that. Then I commit that, save. Okay, and I can click on sync changes. So now I want to comment out the other files that we are not really making use of. So Control A, and let me just comment out all these other files. So the concentration is on NAT gateway, providers.tf, variables.tf, and vpc.tf. Okay, and this one is not needed for now, including this, including the security group. Okay, so we should head over to the terminal. So just place your cursor on any file and open in integrated terminal. So I'll be using batch, and currently I'm on this branch. So basically the initial file that we started with will be in the main branch, and the final configuration will basically be in this branch. Okay, so first thing, let's run terraform init, press enter. So it is initializing the provider plugin, it is finding the HashiCorp version 5.35.0, and then it is installing HashiCorp AWS. Let's give this a moment. So it has initialized successfully, and the log file .terraform.log.hcl has been created for us. We also have this .terraform directory. We have the plugins and the providers binary here. So now let me clear my screen and let's run Terraform plan. So Terraform plan is basically to visualize the changes that will be applied to your infrastructure, right? So it has given us the execution plan. So we are actually deploying 14 resources from our configuration. So all this looks okay to me. I'm not seeing any error. So it is safe to run Terraform apply. And here we go. Do you want to perform these actions? Yes. So yeah, let's give it a moment to deploy. Awesome. So the 14 resources have been added. Now let's head to AWS and confirm what we've done. VPC, and I'll click on VPC. Okay, your VPC by the left, and let's click on these VPCs. And this is the VPC that just got provisioned. If I click on that, we should be able to see that yeah, it's basically our configurations and all that. 4 public subnets have been attached. We have public subnet AZ1, private app subnet AZ1, and in this availability zone we have public subnet AZ2 and private app subnet AZ2, right? So we have the subnet here, right? These are the 4 subnets. So if we go to route table, we have a public route table, and if I check the route from here, let's see what we have in the route. So you can see our internet gateway has been attached to this public route table, right? And if I also scroll up, let me expand this. Going to subnet association, you should see that we have public subnet AZ1 and AZ2 attached to this route table. When I click on private route table, and you see that the route is NAT gateway, all right, just as we've configured, and the subnet association is the private app subnet AZ1 and 2. Right, let's confirm the internet gateway. This is our internet gateway, and is doing just fine. Oh, it has been linked to the VPC. We can also confirm the elastic IP. So this is our NAT gate. This is the elastic IP that has also been attached to the NAT gateway. So this is basically a two-tier setup. You can actually use this network solution to provision your resource, maybe like to deploy your application that doesn't require you having a database, because this is basically two-tier. We didn't create a subnet for, for data tier. So with this, we've actually gotten our network solution right. This is basically how to provision a VPC and its component via Terraform. So remember to come here and run Terraform destroy if you are not, if you are basically just practicing, right? And I can run the Terraform destroy because this is basically to show you how to do this, right? I'm not provisioning anything in my infrastructure, so I don't have any reason to keep this. So Terraform destroy auto approve will help us to destroy all this. So please remember to do this so that you don't so that AWS doesn't surprise you with their bills. All right, thank you so much for watching. I hope you found that interesting. Kindly drop a thumbs up for me by liking this video, subscribing if you are yet to do so. Also click on the notification bell, that way you get notified each time I publish a new video. Get ready to learn more of Terraform, alright? Also share with your friends so they can, tap from this benefit. Thank you so much, and I'm gonna see you in my next video. Bye.